The goal of a classifier, or the goal of a classification problem, is to take the features and predict which class an instance belongs to. So based on feature, predict which class an instance or example. And we're going to work with what are called binary classification problems, which means that there are only two classes. And often these break down as positive or negative, or it could be that we're looking at yes or no, or success or failure. So one classic example of binary classification was predicting loans. So you have all this information about people who have applied for loans at your bank in the past, and you have where they live, you have how much money they make each year, you have other things that you may know about them, and you're going to predict, will they default or not? And you may use that to predict, or maybe you're working in a factory and you want to predict whether or not a batch is good, a batch of products is good. So you have like the weight and different attributes. You can tell is a batch good or not. For our image classifier, we could use something, we could say, is this an appropriate picture of a rabbit? And basically anything where you could answer, the answer could be yes or no, is going to be a candidate for binary classification. So let me give you a very simple example of a very contrived binary classification problem. So because of the two confusion principle, my strategy is I don't want to start with real world data. Because if I'm trying to build a machine learning model to predict baseball scores, and I don't know anything about machine learning, and I don't know anything about baseball, or I don't know anything about how to predict the score of a baseball game, what am I supposed to do? I'm just going to be confused, or I'm going to trust the machine too much. So what I would recommend we do to start out with is start with artificial data. Know for sure what your data looks like, and you can know for sure what should be happening. And then you can understand the classifier better, but you understand this fake data perfectly well. And then that leads you to understanding your model. And then once you understand how your model works and how the process works, then you move on to real data because you feel confident in this. The first fake data set, you had 4 points and you XORed the coordinates. So XOR is like addition mod 2, or let's say they're not both. Let me just write out the data. So 0, 0 should be 0, 0, 1 should be 1, 1, 0 should be 1, 1, 1 should be 0. So this is the data set. So what this is asking is the number of ones even? That's what the class is. The class is 0 if the sum is even, and 1 if the sum is odd. You build this up. So you build this where now you have like 4 variables that are all zeros or ones, and you add up the ones, and if it's an even number, you make it be a 0, and if it's an odd number, you make it be a 1. But this is the starting point. Have you heard of neural networks? Okay. So when the first neural network was proposed, it was just taking the input and running it through. For this example, it would be taking the three, so there would actually be 3 variables. There would be X, Y, and then there would be a constant term that might be needed to fudge things out. And you would plug those 3 in and you would run it. This would be your neural network. You would learn the weights, and then you would add up those weights, and then you'd make your final prediction. And I'm not going to go into details of a neural network tonight. But this was the initial design of a neural network, and it couldn't solve this. It couldn't classify this data set. So people gave up on it and said that won't work. And what they didn't realize was one layer won't work, but you just need to do multiple layers and you can do this. So they kind of gave up too quickly. But this is an example of a fake data set.